Dark matter makes up 85% of the matter in the universe, and we don't know what it is.
I'm Brianna Mount. I'm an associate professor of physics at Black Hills State University, and I'm also the lab director of the BHSU Underground Campus, or the BHUC. The BHSU Underground Campus is a clean room facility on the 4850-foot level of surf. It's almost a mile underground. And it's really opened the door to allowing BH faculty and students to be involved in some of the world's most cutting-edge dark matter experiments and neutrino experiments.
I'll give you the rest. Yeah, I mean, don't have it.
People have detected dark matter indirectly through gravitational effects by looking out with telescopes and seeing the behavior of light. But to actually directly detect a dark matter particle, it turns out one of the best ways to do this is to go a mile underground. The detector that I'm on is called LZ, Lux Zeppelin detector. And so if we had the LZ detector on the surface, it would be completely lit up with cosmic ray radiation, and we wouldn't be able to see that really rare dark matter signal. So we have to go a mile underground to filter out all those cosmic ray signals so that we can see that really rare signal from the dark matter.
Keep your safety glasses, keep your coveralls on for now.
With a big experiment like Dune or LZ, everybody has their own little piece that they provide to the experiment. One of the things that we do at BH is provide low background counting for these construction materials for various experiments at SURF, but then also around the world. The materials that our detectors are actually constructed from are also a little radioactive because everything is a little radioactive. And one of the games that we play underground is how low in radiation can we go? Here we have a low background counter. They basically detect gamma radiation. And so if someone gives me a piece of plastic, maybe two pieces of plastic early in an experiment, they say, okay, Brianna, count these plastics and tell me which one is lower in radiation, because we manufactured this plastic in this way and we manufactured this plastic in another way. Tell me which way we should manufacture our plastic. Further along in experiments, once you know which materials you're going to use, we can count those, say, light detectors for LZ and tell you how much uranium, thorium, and potassium are in those light detectors. And that's really important for experiments because it tells you the background of your experiment. It tells you the noise level of your experiment. All of our low background counters are in collaboration with other institutions. So we work really closely with Lawrence Berkeley National Lab, with Lawrence Livermore National Lab, and with the University of Alabama. We're always going to need to know the radioactive element concentration of all the materials that go into any of the detectors that are underground. Even as experiments come and go, low background counting will always be needed at CERT.
Pedno, and I am a post-baccalaureate researcher at Black Hills State University. We're doing science here at Sanford Underground Research Facility to find dark matter, being a part of the unknown and the discovery, and being one step in the process of finding dark matter in our universe. And it's a pretty amazing experience to go down underground. That culture between all of us is just like the bonding moment of we all get to go down underground that day. We're building detectors, we're making conversation, having fun. We get to coordinate with other scientists like the ones at the Davis and say hi to them if we come up above ground at the same time and we meet in the locker room and stuff like that. We just have a huge connection and a bond down there every time we go down underground. One thing that I like to always say when I mentor people or there's students who don't really know what they're getting into when they're doing physics is branch out and ask questions. My first week of college, I didn't really know what to do. All I know I wanted to do was something with science. I just got into contact with my professor and I was just like, I don't know what to do. And she kind of just took me in her hands and said, do you want to go underground with me? I knew it was a great place right when I had someone inviting who would take me under their belt and kind of show me the reins. And that was like a whole mind-blowing experience that I never thought I was going to be able to go on.
To be able to form a career around something that is so fundamental is really exciting. And I think it's really amazing that our students are here with us doing it, because in their lifetime, they might know what dark matter is. You know, I really hope in my lifetime I know what it is, but I really think in their lifetimes they're really going to know what it is.